Okay, I think we'll go ahead and get started. I think a few folks will be joining us shortly, but let me open up in prayer and then I'll give you a sense of what we're going to be covering today. So, dear Heavenly Father, Lord, thank you for the chance to be working with each of the students in this course. Pray that the material has been clear. Pray that you would help them to better understand what it means to be an engineer. And then for the context of this course, what it means to be a system engineer, getting some hands-on perspectives on that. Pray that you would help them as they begin to navigate their finding the job where they would like to work, and pray that the skills that they've been able to hone here at APU will be able to shine in that process. Pray that you would help in their spiritual formation process, Lord, that all of the times that they've been able to study scripture here at APU, the various times that they've been able to draw out theological principles and how to apply that to their day-to-day life will be helpful. And the experiences where they've had in fellowship and in chapel, all of those are going to build a strong foundation that they can be leveraging in their future. Pray that you would also give us interesting and creative ways for faith integration. In Jesus' precious name we pray. Amen. Okay, well, today probably won't be too long. It's going to be a summary. And so just as a reminder for a couple things that the morning of the final, I'll be sending out the access code to get to the final. And so it will be administered online. And what I'll do for that day, I'll shut down everything in Canvas except the exam. So that one section where the exam is at. It's open book, open notes. And so you can take advantage of all of those things that you have that you've done during the class. I'm going to have this be our last meeting. So Thursday will be just, you can be using that time for study. We've actually made some pretty good progress in what we've been able to go over in the class. And so let's just think, first of all, think about the textbooks and how they complement one another, what we have. And so first of all, we have our main systems engineering principles and practice textbook. And so we've actually gone chapter by chapter through this whole book. And then we've started to think about how we could be applying these things using our SysML development. And so even like on the cover, you might remember these blocks. These are the three main blocks that we covered in the process, and then we got into a lot more specific details. So that's the first textbook that we used. The second one is our practical guide to SysML by Friedenthal and others. And so these are the people that were instrumental in generating what SysML is as we know it today. And so it does give a lot of hands-on practical information about each type of the SysML diagrams and how you would be using those. And it's a good reference that you can take away from this class and utilize it as you go forward. And then finally, what I've been using in terms of my lecture perspective is I've been giving a case study in a NASA mission. And the thing that I've been focusing on mostly is the James Webb Space Telescope. And so as I was able to, I was finding information that we could relate to give us a better sense of what it was like. And so it gets into some of the core missions of what NASA is doing, looking at the origins of the universe, trying to get a better sense of galaxies, distant galaxies, exoplanets, all of this in a platform that's in this special orbit called L2, where it's very cold on the telescope side and relatively warm where all the electronics are and where it sends information back to Earth. So it's in a stationary position relative to the Earth. So it also always is looking, it has a direct line of sight connection to the Earth. But since the Earth is spinning, it's not always going to be the same place. So you're going to need to have multiple ground stations to make that work. Well, that started to get into the discussion I wanted to be thinking about in terms of, well, what have we covered? So it's hard to read, but on the very cover, it's showing some of these three major blocks that we have for system engineering. And so those are concept development, the engineering development, and then the post-development stage. Well, in our textbook, they also included a preliminary section where we talked about foundations and then talking about enterprise-related things and the future of system engineering as we talked about the systems domain. Well, let's think about the formation of the James Webb Space Telescope as a case study, but you can be thinking about the projects that you did and how it would be relating. So you now have a sense of understanding what system thinking is all about. And so the system engineering approach is something you could be using in a lot of different areas of your life. I've done it myself. So I use this term that sometimes you may have to come up with a basis of estimate or a cogent argument with having little or no information. And so how are you going to go about doing that? And that's an example of one of the things that a system engineer is able to do. So system engineering in the modern, the world of modern systems, everything that we have around us is connected. And so it can be very complicated. Now, I mentioned the James Webb Space Telescope. There's a lot of different elements that go into that. It has various payloads to do different things, spectrographic information, imaging information. Those are things that are available with that. And so that's would be like the context of what we're thinking about as I'm trying to walk through this summary of what we've covered. So to make a complex system function, it's so complicated that you just can't go into the lab with, solder components together and make it work, because there's so many things that have to come together to make it all happen. And so thus we can see a motivation for what we're trying to do in system engineering. So that's a little bit of the foundation. So we got a chance to spend 4 lectures talking about that. Then we got into the concept development. So let's think about the James Webb Space Telescope. So if we think about that, why did they make the James Webb Space Telescope? We had Hubble. Isn't that all we needed? And so that's where we get into this needs analysis and evaluating what's out there. And what they were seeing is that, yes, we could get great imaging and some spectral information from Hubble, but there were limitations that were part of that. They decided to change the spectral regime, going more in the infrared. And so what would be the ideal platform? How large would it be? So what does it need? And so something that NASA and the National Science Foundation work together, they have a decadal survey. Once every 10 years, they figure out what is the science goals that they need to be doing. And so thus, NASA is starting to say, okay, what is the needs that we have? We've gotten this great type of thing, imagery and various things that scientists have been able to use with Hubble and ground telescopes, but still there was a gap. And so that's when you start to formulate as a needs analysis to figure out, well, what is it that we're looking for? And so this is you start with the what, and then you start to figure out how. The requirements analysis, okay, what specifically is it going to have? And so this is where we get into, it eventually gets into these kind of things where we have specific instruments that are trying to capture the things that you would need to do to meet those specific needs. So needs flow into requirements. Requirements always have a shall statement. It has a single thing that you're trying to accomplish with that requirement. There can be multiple layers of requirements. Say you might have a top level architecture and operational concept that you have to fit in, and then you have to figure out, well, how is this going to work? You're still going to have Hubble, you're still going to have ground assets, you're still going to have other space telescopes. And so where and what is the James Webb Space Telescope going to do? Then you get into some functional analysis. You talked about, okay, we're going to be looking back at distant galaxies to characterize those better. Well, how distant? How are you going to characterize those? And then it starts to get into functions. And so then you start to get into, okay, what exactly are some of these subsystems actually going to accomplish from a functional level? and say you have some evaluation and selections. Do we really need to go to the infrared regime? What part of the infrared regime will we be looking at? Near IR, mid IR, long wave IR? All of those have associated things that are required that you would need to be imaging in those spectral regimes. And so we get into the evaluation and selection and recommendations. It's fitting within a architecture. And so how does a James Webb Space Telescope fit in with that overall architecture? There would be other things that say, if you were to read up on the James Webb Space Telescope, it can actually look at the outer planets in our galaxy, but it's purposely intended to block from the sun. And so it can't get good images of Mercury, for example. And so those are some of the trades of what it can and can't do. So in terms of an architecture, what's going to be done on this platform, what's going to be done in something else. So you can see there's a lot of big picture things that are being thought about as we go along through that. Well, I'm going to jump over to the model-based system engineering chapter and focus on some of the charts that I shared with you that we're talking about SysML. And just lightly have a chance to be talking about this. And so Freudenthal, the practical guide to SysML, is where this starts to come in. And so there are various useful documents to help us to see how this kind of process is going about and helping us. So we actually looked at all 9 of these types. You at least did one of those. And so the first thing we talked about was a use case diagram. So this is just a stick man and a system and what it actually does. So it can be very useful when you're starting to try and communicate with a stakeholder. What is it that you want to do? I was mentioning about the needs analysis and then folding it into requirements. You're trying to capture what exactly that is intended for it to actually accomplish. And so this is part of a behavioral diagram that we looked at. One of the ways that can be helpful for giving you a top level way of understanding, well, what are the elements of that system? That would be looking at the block definition diagram, so you can remember some of the things that we covered in that regard. The internal block diagram is for one particular block. And so I was showing you an image of the antenna. So let's say you want to be looking at the antenna. And so it turns out that the James Webb antenna actually had modules that when it's launched, it's actually collapsed and it's deployed. And then each one of those hexagonal parts of those mirrors can actually be in a very precise way aligned on orbit to make sure that your aperture is performing as best as possible. So those are a couple things. And so we talked some about the behavioral and the structural. We can get a lot more in depth for how a process actually works when we look at the activity diagrams. And I showed you with the system of system architect or Cameo Systems Modeler, there's some overlapping modules in both of those things. You can actually execute an activity diagram. You can execute a state machine diagram. There's various ones of these things that you can actually check out the logic. So a sequence diagram, I like to think of trying to include a temporal relationship. So what communicates to what? So how does that process actually go? And so we got a chance to be exploring that. State machines is like, say, you be in a launch configuration, then you have an early orbit checkout for the James Webb, and then you finally get in a deployed state. Then it can have one or more of the science instruments that are engaged. All of those are the things that flesh out and fulfill what we're doing in the behavior side. The requirements is something on its own, and so you can be showing a tree way of showing the requirements. There's a couple of different ways that we could be doing that. You could have things in a table. Those are also a useful way of representing requirements. And then packaging, this is how we start to show where things are going to go in your system. And so you're trying to have them in functional groupings. There's other ways that you can be using a package diagram. Say you're trying to give a perspective on your overall model. What are you going to include? And so we showed an example about that. And then we finished up with what may be an interesting and at times might be a little bit challenging to follow is a parametric. And so this is when you have constraints and you have the ability to include that. So we had discussions about, well, what have we learned from doing our SysML modeling? That was one of the topics that we got a chance to be thinking about. And so basically you can see it gives you a structure where you could then go into more depth. You did this high level assessment and you forgot, well, this is something that I need to flesh out in more detail. And we did that. Then there was a couple other chapters here where we had decision analysis and support. And so you can have, say you're trying to evaluate several competing possible implementation options. And so you can have this decision analysis support approach that can help you to give a way that you can have like different key requirements or things that have to take place, and you can decide which one you would want to go forward with. And finally, we had a chance to be looking at risk. And so that's the first part where we talked a lot about the concept development. Then we got into the engineering development. And so now the system engineer is about at the same level as a development engineer. So they come alongside. And so the system engineer is still trying to keep this larger perspective while now you're actually building it. And so this is the second major block that we see on our cover where we get into the engineering development phase. And so we're bending metal, we're getting ready. So first of all, there's the advanced development. So we see there's some high risk items. And so say we have to do a prototype of some things. Maybe there's a new technology. One of you were looking at electronic vehicles. And so you can use this battery type or another battery type. What type of things would I be using for a nuclear power plant? What type of nuclear material? Stuff like that could be things that would be traded. We had a chapter that talked about the software side of things that have to be thought through. And then we got into more depth of the engineering design. So you were focusing on, say, one part of your system engineering design. We are still focusing more on the concept area for our SysML development, but you could easily have taken that and gone even further as a result of what you did at that top level. Then we talked about the integration, that you have to not only come up with a concept, not only build it, but you need to integrate it with other things. And then we have to finally test and make sure that everything is working the way it is intended to go. So that's the second of the three main things that we do. And then after we do the development, we get into production. Maybe there's more than one article. Elon Musk is, I think he's tooling up one or two things based on some of the things he's been putting on Twitter as of late, of how not only you build a prototype, but you have to make it so you can make lots of them at an affordable price. So you get into a production mode, which is different than doing the first article. How is it going to be operated? The James Webb Space Telescope, guess what? When it's launched, you're never going to have some servicing mission. It's going to work until it doesn't work anymore, unfortunately, but it has it in this orbit that they decided this is going to be really, it's worth it. And so they're actually now reaping the benefits of a lot of time, effort, and money to make that happen. Then we finish up by thinking of systems engineering. So you can be thinking about Hubble and the James Webb Space Telescope collaboratively focusing on one astronomical event. That's something that is now being done. And so we can begin to see how multiple systems can fit in together. And that gets into the last part where we start to be thinking about these enterprise system engineering, how we can be thinking out there can be the coalition of the willing. And we talked about how central that enterprise is manifested, or is it just a coalition of the willing? There can be that diversity of possibilities that exist. Then to finish up, we talked about security. That's an important thing that you're thinking at the system level. What are the single points of failure? One of the things that how you can be making sure that it's going to be robust and the information is protected. And finally, we talked about the future of system engineering. It looks bright. And even there's interesting ways that it can be applied in new areas. And like one of the things I've been looking at is at how to apply system engineering towards biological systems. So that's just a little bit of a quick rundown of a summary of the things that we've covered in this class. Let me see if there's any comments or questions that you all have. So one thing I will remind you is to make sure that you double check that you don't have any missing assignments. One or two of you do. And so maybe just look and see if you finished all your quizzes or if there's ones that you haven't done. So this is about the time I have to put 0 for the ones that you haven't completed. That doesn't mean you can't fill those in. So go back and double check. And just as a heads up, at least one of you has a handful of quizzes that weren't done. So please complete those because I don't want to give you a bad grade any worse than I need to. So that's just another little bit of encouragement on that front. So for me, this has been a really fun course to teach, and I hope you have enjoyed it as well. It's a shame that it's coming to an end, but for most of you, I think you guys are finishing up. And it could be in a matter of months that you're going to be working at some company that's paying you to do this. And so there's expectations that go along with that. It's going to be a whole new chapter in your life, but I hope it will be a positive one. And for maybe some of you that have maybe another semester or so, I look forward to be getting a chance to be seeing you in the fall. And as always, please stay in touch. I'm on LinkedIn. And so if you want to look me up there, I'd be glad to track what you're doing in your career or just send me an email. Those are also some things that you can be aware of. So just one last final time, any comments or questions that people have? Okay, well, I'll go ahead and end the recording there. And let me get out of this. So thank you very much, everybody. See if my system will cooperate.